Okay, so we're going to do the second part of objective 5.6. Our last set of notes, we were learning about the log properties and how to use them to expand or condense logarithmic expressions. Today, we're going to learn how to use the change of base formula to help us solve a log that's not a base 10 or a natural log of base e, because our calculators have base 10 and our calculators have base e. So first, we're going to use the log properties that we learned, so we'll review them, to approximate log values without a calculator, just to remember what we were doing last week with our assignment. And then I'm going to give you the formula to solve a problem like this. For example, if I say the log of 7 base 2, well, you can do the log of 7, or you can do the log of 2 with your calculator, because your calculator will do the common base 10, or you could do the natural log of 7 or the natural log of 2 because your calculator has a button. But your calculator doesn't have this button. Desmos does. The graphing calculators do, if you know how to find it, but these little ones don't. So I'll be providing you with the formula. But before I do that, I just want to brush off our skills from last week, and we're going to use some log properties to find some logs without a calculator. Okay, so a couple things to remember. First of all, remember that when we solve a log, for example, let's say I say the log of 3. And you solve it, what you're solving is for an exponent. That's what you're looking for. This really is a base 10 log that says 10 to the exponent equals 3. That's what it says. So anytime you solve a log, you're finding an exponent, which is really helpful when you're trying to do a problem like this. Actually, when you're doing a problem like that, let me rearrange. See, I don't know how to do that, but I can do that. And it'll give me the exponent. It'll tell me what it is. So logs are really useful when it's difficult to find the exponent in exponential form. Okay, so I just wanted to remind you that that's what we're working on. Today we'll be finding the exponent that is found from solving a log expression. Okay, but first I would like to just go over the properties that we will be using often today. And that is the property that says, there's 4 of them, so you need to squeeze that in the top part of your notes right there. Squeeze them in, write it small so that you have room. If I say the log of b base b, you should be able to tell me what the answer to that is. This is log property 2. The log of b base b is 1. And you need to know that. Okay, that's log property 2. Why? You're going to have to, on your quiz, do a little matching statement or a little fill in the blank. How do I know that the log base b of b equals 1? Because b to the 1 equals b. Remember, it's just bring the base out of the basement and switch. Okay, so that's a true statement, and that's the reason we're supplying for that. But if the base and the log are the same, the answer is 1. Okay, the other properties we're going to be using is property 5 that says if we have the log of m times n base b, sometimes it's not really helpful when it's condensed like that. So if we were to expand it and we wanted to solve, say it said 2x instead of m times n, then we would do what to expand? Right. Okay. So what's really important today is that you supply me with the written words or the written explanation to the statement. So this right here says the product of a log, product, m times n, is equivalent to the sum of logs. It's really important. On your quiz next week, you will be doing a matching assignment where you have to match the mathematical statement with the written statement. Okay, so this is part of the reason we're writing it down. All right, we also will do properties, so that's property 5. This is property 2. Based off of our textbook, other textbooks might name them in a different order. It doesn't matter. Number 6, which says the log of m over n base b is equal to minus log n base b. Exactly. We need that property to help us solve these problems we're going to be working on. So what would I call this in written word? Not the product. What is it? The quotient of a log. I always like to use a capital Q for quotient. You can, of course, write the word out if you want so that you can remember it. Is equal to not the sum of logs, but the difference of logs. You got it. All right. So that's my written statement for my mathematical statement for my log property, number 6. Then the last one that we will probably need for today, and these are typically the most popular, you see them the most often, is property 7 that says the log of m to the p base b is equal to, power down, p times the log of m base b. And again, it's really important that you can tell me the written words that say this statement. Starts out the same. Instead of the product of the log or the quotient of the log, this is the power of a log is equal to the power times the log. Yep, the power times the log. Okay, so I'm going to be writing some proofs today to solve these problems. And I'll challenge you by offering you some extra credit if you want to try some on your own. They'll be structured pretty much the same way mine are. But next week, we're going to be solving some equations. And while I won't be asking you to write your own proofs to solve the equation, I will give you some equations that are written in proof form, and I'll write them all out of order, and you have to rearrange them. So I just want to practice introducing them to you today so that when you see them next week, it's not a foreign, brand new, like different language. Okay? All right, so let me introduce a proof to you first before we go and do the next part of our notes really quickly, and you can put it on the back of your notes if you want, or you can just watch, which is totally enough to just watch and absorb. So I'm going to start off with a really simple problem. Back to basic pre-algebra, and I'm going to write a statement. If x plus 5 equals 10, then x equals 5. This is a true statement. When you're writing a proof, you have to show how you go from this to this. And not only do you have to do the mathematical statements, you have to supply the reasons that your proof that your answers are correct without skipping any steps. So a proof goes like this. It's usually, sometimes you'll write it in a paragraph form. I never like to write them in paragraph form because I don't like to grade them in paragraph form. So I like to see them in 2 columns, where on this side you make your mathematical statements, and over here you provide the reasons for making those mathematical statements. So what it goes like this. It goes step 1. You'll write down the if statement, or sometimes it'll say given instead of if, and it'll say prove instead of then sometimes. Okay, it comes in multiple forms. Now, my reason for writing that down is because that's the problem I was given to solve. So statement 1's always easy. You just write the problem down and you write given. Statement 2. Now, you know I'm about to subtract 5 from both sides. Correct? Now, typically, we'll do this all in our head. But when you're writing a proof, you provide every single step. So I would write x plus 5 minus 5 equals 10 minus 5. And when you do proofs, you write them horizontally and not vertically, so you don't write underneath. Now, over here, I'm going to state what I did. I did the subtraction property of equality that states if I subtract something from one side of the equation, I have to subtract it from the other side. Hey. Okay, step 3. Now, with you, typically what you'll want to do is you'll want to simplify this and write x equals 5. But in a proof, that's not necessary because the answer to 5 minus 5 comes from a different rule than the answer 10 minus 5. So when I do this properly, doing a proof, I would write this as x plus 0 equals 10 minus 5. And I would connect this statement to its replacement that said, this is what we call the additive inverse. When I add a number plus its inverse, I always get 0. With me? Then my next step, it's only got 2 more, so relax, stick with me. I would say x equals 10 minus 5. Does anybody know what property or what rule says if I add 0 to something, I get that something? Nope, it's called additive identity. Shh. Because if I add 0 to something, it keeps its identity. Don't zone out on me, I'm almost done. Then I go to step 5, x equals 5. And I did this one. What did I do? How did I get from 10 minus 5 to 5? I use substitution. And this is what is considered a proof. So for every step you take mathematically, you provide a written explanation of rules or definitions or properties, etc. So I've introduced you to the proof today. And I'm introducing it so next week it's not an unfamiliar thing. I will be writing the proofs for you every time. You might have to fill in some blanks or rearrange some steps. Question? So here we have a problem that says, find the approximation of logs given these specific values, the log of 2, and I'm not going to say base 10, it's the common log, okay? The log of 2 is 0.301, and the log of 3 is 0.4771. Okay, so that's all I have. Now, I realize I can go into my calculator right now, and I can type in the log of 18. Because my calculator will do the math for base 10, and it will tell me the answer. But I want you to use the log properties right here. I'm writing on it so it shows on my video to solve this equation without a calculator. I want you to use your brain. So how does that go? How does that go? I know the log of 2. And I know the log of 3. I don't know the log of 18. But I think I can make 18 an equivalent statement with 2's and 3's. I can replace or substitute 18 with, do you agree that 18 is 2 times 9? Yes. And 9 is 3 times 3. So I could replace 18 with the log, don't write this down yet, of 2 times 3 squared. I can do that. Yes? And that's helpful because then I can do this by myself without my calculator. So I'm going to do this in a proof. And if you don't want to write the proof down, of course you don't have to. I'm not going to make you, but you will be doing them next week, and so you might want to have a reference. It's up to you. If you are going to do the proof, make sure you're writing really small so that you can fit it in the space. So I will be doing this as a proof, and I'm color coding. So if you wanted to take a moment, to just color code our properties that you wrote down at the top of your notes so that you can see what's happening. I'm going to color code my steps. Okay, so here I go with step 1. And typically it would say, fine, if the log of 18, then the answer is 1.2552. Okay, but we're going to modify the proof a little bit. So the first thing I'm going to do is I'm going to write the log of 18, and I'm not going to write base 10, okay? That's redundant. I know it's base 10. I don't need to write base 10 to know that. And my reason over here is, give it. Step 2. I'm trying to solve this, but I don't have the value of the log of 18, and I'm not allowed to use my calculator. So I'm going to convert, or I'm going to substitute the log of 18 with the log of 2 times 3 squared. It's a true statement, and it gets me closer to what I'm looking for. So step 2, what would be my reasoning? Substitution. I'm just replacing 18 with a substitute that's equivalent. We call that substitution. Like, for example, if I do 10 minus 5 equals 5, that's substitution. They're equivalent statements. Okay? It's more of a simplification than anything else. Okay. Step 3. I don't know what the log of 2 times 3 squared is. I know what the log of 2 is, and I know what the log of 3 is. So I'd like to separate them. So I'm going to apply property 5. This is log of 2 plus log of 3 squared. Now I'm getting to the point where I'm going to show you something about the structure of a proof. So this is log property 5. Do you agree? Okay. Log property of 5 started up here with the product of a log. Yes? And it turned into the sum of the logs. So this first statement, part 2, step 2, is going to be the beginning part of my statement right here. The product of a log. And then this part right here equals the sum of logs. That allows me to go from statement 2 to statement 3. That's log property 5. Okay, so connected. The product of a log in step 2 converted to the sum of logs, step 3. And I'll highlight that. Okay, moving on. Step 4. So I know the log of 2, yes? Do I know the log of 3 squared? No, I know the log of 3. So what should I do here? Power down. So the log of 2 is equal to 2 times the log of 3. Step 4. So that's property 7? Yes? Okay, so I'm going to grab my highlighter and I'm going to connect. That's not purple. That's not blue. Try again. Blue. The power of a log equals the power times the log. Connecting step 3 to step 4, my statement says the power, that's not a P. Try again. Power of a log equals the power times the log. All right, keep going. You with me? Now, am I able to now do some substitution? Do I know the log of 2's value? Yeah. Yes, it is 0.3010. 2 times, I know the value of the log of 3. It is 0.4771. What do I call that? That's right, it would be Substitution. I'm substituting one value with an equivalent value. Okay. Then step 6, I just finish that up, and my answer is approximately, because I'm rounding to 4 decimal places, 1.2552. And my reason? Substitution. I'm just substituting a mathematical statement with an equivalent mathematical statement. Over here, we're going to make sure it makes sense. We said that the log of 18 is equal to approximately 1.2552. That's what we said. How can we verify that that's true? Or 10 to the 1.2552 should be approximately 18. I think it's 7.996 something. It's close. It's an approximation. Logs are usually approximations. That's why we go to 4 decimal places, so we can get a semblance of precision. Okay? So there's your verification. On your homework, here's what I expect to see. If you want to give it a shot, this is 1 point. This is 4 points. Even if you get it wrong, if you attempt it. If you want to practice, I think it will be good, but I'm certainly not going to force it. It's tough. Okay, next I want to skip to C because B is a little more challenging than C. Okay, here we go. We have the log, base 10, of 7/500. But I don't know this information. All I know is the log of 2 and the log of 3, and that's all I know. How can I convert 7/500ths into 3s and 2s? So I'm going to give you a second. Okay, so by your suggestion, you converted this to 3/4, this, and then you converted that to 3/2 squared so that you could be using 2s and 3s. That's brilliant. Exactly right. Good job. All right, so I'm going to pump up my proof right now and go to step 1, writing the problem down. Log of 3/4 is my given statement. Here we go. Step 2, conversion to the log of 3/2 squared. Reason? Substitution. Step 3, what property? I don't know the log of 3/4. I don't. I know the log of 3 separate from the log of 2. So what should I do? It's property 6. You got it. So the log of 3 minus the log of 2 squares. Definitely want to separate my logs so that I can replace them with their values. So that's 7, you said. So I'm going to come up 6. You did say 6. Thank you. So I'm going to grab my purple highlighter, and I'm going to go the quotient of a log equals the difference of logs, correct? So the quotient of a log equals the difference of logs. Okay, good job. Now, I'm getting to a point where I'm feeling pretty comfortable. I'm going to be able to find the answer to this. I know the log of 3, but I don't know the log of 2 squared. And it's not 0.301 squared. It's not. So what do I have to do? Property 7, I have to power down. So I'm going to do the log of 3 minus 2 times the log of 2. So that's property 7, right? So from here to here. So the power of a log equals the power times the log. You're getting there. Okay, good. Good, good, good. So that's step 4. Power, I keep doing that. power of log equals power times log. There we go. Now I can substitute. I know the log of 3. I know the log of 2. Log of 3 is 0.4471 minus 2 times point. If you're going to talk, I'm going to stop. Okay, that's substitution, correct? And then all I do is plug that into my calculator, and I get the answer, approximately negative 0.1249. And step 6 is also substitution. I ran out of room. I'm going to go back and highlight the fact that I connected those two statements in blue with statement 4. Okay, so now we're just going in for the check. We're saying that the log of 3/4 is approximately negative 0.1249. And we would check that by converting it to 10 to the negative 0.1249. And we should get approximately 0.75. It's true. I checked it. Okay? All right, last one. Wait, let me go back. Okay, this last one I'm not going to write as a proof. We're just going to solve it. And this one's a little more challenging because you're finding the log of 2.5. But for the life of me, I cannot break 2.5 into 2's and 3's. But I do know the log of 10 is 1. And 10 divided by 4, which I can break down into a log of 2 squared, is 2.5. 10 divided by 4 is 2.5? Yes? Okay, so something I had to think about here was that I knew, basically, that the log of 10 equals 1. I should have known that. That's property 2. So anytime you're doing these problems, my suggestion is you write that one down as an additional option for use. Okay? So I could write this as an equivalent log of 10 over 4, which I could write as the log of 10 over 2 squared. Do you agree? Okay, so I'm going to just go ahead and replace this with the log of 10 over 2 squared. Substitution. Now, I don't know them together, but I do know them separately. Using the quotient rule, I'm going to subtract my logs. And I'm going to power down. So the log of 10 minus 2 logs of 2. You with me? And now that I have them totally separated, I know the log of 10 is 1. And this is 2 times, so minus 2 times 0.3010, which I can then in turn plug into my calculator. So that was substitution. Here's substitution. 0.03980. Notice that I went to 4 decimal places. The 0 is insignificant at this point, but it doesn't matter. That's the rule when you're doing logs. You go to 4 decimal places. For the check, we would say that the log of 2.5 is equal to the exponent 0.3980 because 10 to the 0.3980 is approximately 2.5, and that should be an approximate. And you don't have to come and say, Mrs. Frame, did I get this right? Because you have the ability to check your work yourself. Just plug it in. You found the exponent, plug it in. See if it equals the log. Okay, so there is your brain power section of the assignment, and you have 6 of them to do, the odds. If you write them as proofs, you can get additional points. Don't write the proofs for the evens, or you can, but I won't give you extra credit for them. Okay? They're already extra credit on their own. All right, so now we're going to go to the easy part of the assignment, which you will be quizzed on next Monday. How to find the answer to the log of 5 base 3 or any log that's not a common log, like it's not a natural log or it's not a base 10 log. Shh. There is a formula, and I think yours says if A and B and X are positive numbers, and A doesn't equal 1 and B doesn't equal 1, I dropped the A. Okay, I dropped it. I don't think it's necessary, so cross it out. Okay, then, so if this is true and B does not equal 1 and they're not negative, they're positive, then I can say that the log of X base B is equal to, there's the formula, I'm about to provide it to you. The log base 10 of X, but don't write base 10 because that's silly. All I'm doing is I'm just converting it to the common logs for my calculator so the calculator can do the math. The log of X over the log of B. And I'm going to highlight a little bit here. Log of X goes in the numerator. Log of B goes in the denominator. And I exchanged them both to the same log. They're both base 10 now. It's not a base 3 or a base B. It's base 10. And this works with the calculator every time. I think it's really interesting. You can also have this option. If you're being lazy and you don't want to write 3 letters, log, you can write natural log of X over natural log of B. It doesn't matter if you're feeling lazy, use the natural log. You have that button on your calculator too. It works exactly the same. So it's your choice. I suggest you go back and forth. Okay? You'll get professors that will only ever use a natural log because they're lazy. And then you'll get me. Sometimes I forget and I just write log all the time. Okay, so here we go. It says find the log of 5 base 3 to 4 decimal places. So basically, I'm going to take this, and this equals something. We're supposed to figure out what it equals, right? So to convert it for my calculator, I'm going to write this as the log of 5 divided by the log of 3, or the natural log of 5 over the natural log of 3. So here's what I want you to do. On this side of the room, do the natural log. On that side of the room, okay, so you three, you guys, from Seth this way, natural log. Lane that way, log. Do it. Let's see if we get the same answer. On the natural log side, what'd you get? 1.497? So 50. On the log side, what'd you get? The same thing. Whoa. Cool. All right. So we proved that it doesn't matter which form of the formula we use. Let's do the next one. So you're going to do either the log of 3 over the log of 5. Switch. You guys now do the logs. You guys do the natural logs. I think it should be less than 1. Because it's 5 to some power equals less than 5. So point on this side. Come on, guys. On this side, somebody. 6826 on that side. Same thing. There you go. Okay, so here's what I want to make clear on your homework before you go crazy and start doing it. Your homework. On the last 4 problems that you're assigned, you have to use your formula. My expectation is you write the problem, you write the formula, and you write the answer. Then you check, is 5 to the 0.6826 equal to 3? Check it. Practice checking. Okay, and summary and